Today we're going to talk about the area of a triangle and a parallelogram. You know the formula for area of a triangle is 1/2 base times height. That's only if you have a right triangle. If you don't have a right triangle, you have to use this other formula instead. I'm going to represent K for the area is equal to 1/2 your two sides, A and B, sine of the included angle, sine of C. So as long as you have two sides and the angle in between, which we call the included angle, you can find the area of a triangle. This formula is given to you on your reference sheet, so you don't need to memorize it. Formula for area of a parallelogram, however, is not. But the only thing you have to remember is that a parallelogram is made up of two triangles. So instead of the formula being 1/2 AB sine C, it's just AB sine C. Just drop the 1/2. Example 1. Given the triangle at the right, find its area. Express it rounded to 3 decimal places. So if you look, you have two sides and the included angle, the angle in between. So we can use the area of a triangle formula. So it's going to be K equals 1/2 times my two sides, 12 and 18, sine of the included angle, sine of 94. Make sure your calculator's in degrees, type it in. Round it to 3 decimal places. It says you will get 107.737. This next one is a parallelogram. Find the exact area. So for a parallelogram, we know to drop the 1/2. We need the two sides and the included angle, and we've got it. So it's going to be 10 times 16 sine of 60. It does say exact. So I'm going to do 10 times 16 first, and I get 160. And I'm going to type sine of 60 next, which is radical 3 over 2. This is the same as 160 radical 3 over 2, which when I reduce is 80 radical 3. So exact, remember we just take separately. I'm going to save the two problems here for you. I think you can handle those. Those are the easier ones. I will concentrate on the other ones here. A garden is in the shape of an isosceles trapezoid. The lengths of the parallel sides are 30 and 20 feet, and the lengths of the other two sides are 10 feet. So a parallelogram looks like this. Isosceles trapezoid looks like this. The parallel sides are 30 and 20. The other sides are 10. We want to, at the base of the trapezoid measures 60, the base angles. We want to find the exact area. Well, a trapezoid, you can split it into two triangles, however they're not equal. So we got to find the area of each triangle separately. Let's start with the bottom triangle. The bottom triangle, we've got our two sides and the angle in between. So that area of the bottom triangle is going to be 1/2 times 10 times 30 sine of 60. 1/2 times 10 times 30 is 150. And then sine of 60 is radical 3 over 2, which that will reduce to 75 radical 3. Now to find the top triangle, you need two sides and the included angle. Right now we're missing the included angle. What we do know about the trapezoid is that adjacent angles add up to 180. So if this bottom one is 60, this top one needs to be 120. They're supplementary to each other. So that area is going to be 1/2 times 10 times 20 sine of 120. 1/2 times 10 times 20 is 100. Sine 120 is radical 3 over 2, which is just 50 radical 3 when reducing. The exact area of the whole garden, just add up your two triangles, 75 radical 3 and 50 radical 3 to give you 125 radical 3. And finally, the last one that we'll do together, and then you guys can do the problems that I skipped. Aaron wants to draw a triangle with the following information. So, we have triangle ABC. AB is 15, BC is 18, and the area is 40. We want to find the sine of angle B. So we know our area formula is 1/2 2 sides sine of the included angle. Fill in what you know. 40 is equal to 1/2 times 15 times 18 sine of C. Half of 15 times 18 is 135. Divide by 135. So you get sine of C is equal to, when that fraction reduced, which is 8/27. That's what the first question asked. Now the second question says find to the nearest tenth the measure of angle B. Well, I'm sorry, I have C's throughout, but these are really B's. If we know sine of B is equal to 8/27, to find what B is, just take your inverse sine. So inverse sine of 8/27 will give you, to the nearest tenth, 17.2 degrees. And this last question, is it possible for Aaron to draw true triangles that are not congruent, that satisfy the given conditions? So we have, remember we have 15, we have 18, we have 17.2. Wants to know, can I make two triangles? Well, I would have to determine this, I would have to find this third side using law of cosines and then find all my angles. And I'm not going to spend the time to do that. I will just say, let's just have you guys finish the top two problems there that we skipped, and we will continue with this practice tomorrow.